The aim of this session is to discuss how to check for normal distribution whilst using JASP. Here's the data set I created in a previous video where we've got reaction times for a congruent situation, reaction time for an incongruent situation, and the exercise grouping with the grouping value label set over here on the right hand side. Now, in terms of checking the distribution for JASP, we go up to the descriptives menu, click on descriptive statistics. Now, JASP opens a new output window for here, but at the moment nothing is created because we've not moved anything over here in terms of creating the file. So as I move things over, we start to get and see new output appearing over here. Now, I would want to check the reaction times for their distribution for both, or all three I should say, of the exercise groups. So as soon as I add this split in here, you can see how the file changes again. Now, as default, we get a mean, a standard deviations, and minimums and maximums, which is good and useful for us in terms of checking our distributions, or in terms of understanding our descriptive statistics, I should say. In terms of adding some graphs, if I click on distribution plots, we get the histograms. Again, it's a case of looking at the overall shape. In this particular graph, it looks like there's a tail out to the right hand side, which indicates some positive skewness, and even worse over on here on this particular graph. If I add box plots, I'll create a new box plots for us down at the bottom. Here are those box plots, and it's identifying that there are some outliers. I would like to know who those outliers were in case of which participants are being identified as outliers, 7, 20, so on and so forth. In terms of working who those out, let's have a look for number 35 over here on the data file. Let's scroll down, number 35, there they are in terms of their scores. So you can identify them by looking at it. Okay. Let's go back to the output screen. You can use these arrows either side to move between the screens and the data screen. Going to add some QQ plots. These QQ plots are much more second year stuff or level 5 in terms of adding it. But it's a case of essentially how close do these little circles follow the line. Where there's rather large deviations or some snaking around the line, it's indicative that we've got problems. Where it follows the line quite closely, much better. So far, we've looked at graphs. There is a hint of problems within this data set in terms of a lack of normal distribution. Let's add some numerical checks to our graphical checks. So here's the mean selected as a default. I get the feeling I'm going to need a median at some point in terms of being able to provide descriptive statistics for data that is not normally distributed. If I've got a median, I would like an interquartile range to go along with it. In terms of providing some numerical checks of distribution, we want our skewness and we want our kurtosis to be checked. And we want to add Shapiro-Wilk, which is something I will be talking to you guys about depending on the different year group that you are in. Here's our new table in terms of looking at things. Now this is quite a large table with quite a lot of numbers in it, and I need to be able to perform the calculations. So in terms of checking the distribution, we need to look at skewness divided by the standard error of skewness and kurtosis divided by the standard error of kurtosis. I could quite easily open up a calculator down here and work my way through one by one all of the calculations. But because I have 3 groups and I put 2 variables in there, I don't particularly want to take that amount of time. If I click on this little arrow here and go to copy, I can move this file, or that table I should say, over into Excel. That then allows me to set up equations to work out where the differences are. So I'm going to click in a cell here, click on equals, click on the cell above, divided by the cell below, and there we go, we get our first skewness calculation. Now it's quite simple, we'll move that across, copy and paste that in for all of the separate calculations, and because I know how Excel works, I can do the same thing for the kurtosis ones because it is using the same equation for all of those cells. So what am I seeing here? Well, we've got a skewness value that exceeds the +2 criteria. 1.96 or 2 are the criteria that we use to determine whether data that comes from a normally distributed population. This particular value is in excess of that. That's not normally distributed in terms of the skewness. The kurtosis value, however, is fine, but if we lose skewness, the kurtosis value is secondary to that idea. If we look at the warm-up group, both of these values vastly exceed the +2, -2 criteria in terms of what we're seeing. Moving forwards, lots of issues with the distribution of the data. Shapiro-Wilks is supportive of this, where you see a probability value less than 0.05, which we have here in a number of our situations. I'll just try and highlight all of those cells. It is indicative that our data does not come from a normally distributed population. For the ones I've highlighted, that is supportive of our skewness and our kurtosis calculations. So within this data set, we've got issues with the distribution for some of our groups. We need to consider how to proceed, because this will dictate some of the tests and choices we make in terms of the analysis that we follow.